Hello and welcome everyone to this optional video about formal fallacies. We did not get to cover this in class, which I had planned to do on Wednesday, November 24th. Since we didn't get to it, it will not be on the exam, but in case you're interested, here it is, section 8.6. So we are only covering this section in this video, and I will be adding a couple interesting things to the end of it as well. All right, so think about modus tollens. In modus tollens, we learned that if we have a conditional and we also have the negation of the consequent, we can infer the negation of the antecedent, okay? So that's how the argument is supposed to go. The thing is that people mess this up often. Not only do they mess it up often, but they mess it up in the exact same way, and here it is. I mean, there's certainly different ways you could mess up modus tollens, but here's a very common one. And it goes like this. You have a conditional, and then you have the negation of the antecedent, right? And then you infer the negation of the consequent. It's supposed to go the other way. Negate the consequent, infer the negation of the antecedent. So when we do it this second way here, what we're doing is we're denying the antecedent. Right, so this fallacy is so common that it gets its own name, the fallacy of denying the antecedent. Denying the antecedent. You're not supposed to do that. And let's see why. If you were to put this in a truth table, you would find that there are instances where the premises are true and the conclusion is false. So we can see through a truth table that it's invalid. You can't prove it through a proof that it's invalid because proofs are used to show validity, and you would just keep going in circles forever if you were to try and prove this invalid argument here. There's just nothing you could do. You would hit a brick wall. Okay. And so let's do this. Let's try and use a counterexample, meaning we will give an argument which has true premises or could have true premises and a false conclusion. So this is a counterexample to this argument form. All right, first premise. If it snows tomorrow, I will cry. It will not snow tomorrow, therefore I will not cry. Okay, so you see this form happens like this, the messed up way, this invalid way. This argument commits the fallacy of denying the antecedent. So we have a conditional up here. If it snows tomorrow, then I will cry. It will not snow tomorrow, so I'm denying the antecedent. Does that mean I will not cry? So think about that. Couldn't it be true that that if it snows tomorrow, I'll cry, and it doesn't end up snowing tomorrow? But couldn't I still cry? Right? I might still cry tomorrow. I could stub my toe. I could watch a sad Hallmark movie. I could cut onions, right? So there's lots of other ways that this conclusion could be false, that I will not cry, meaning that I do cry, while the premises are true, okay? So hopefully that's a clear counterexample for you. The next one, conditional elimination, also known as modus ponens. Here's how it goes. If P, then Q. P, therefore Q. How to mess up conditional elimination or modus ponens? It's easy. All you do is you, instead of also having the antecedent here, so you have, the way it's supposed to go is you have a conditional, and then as your other premise, you have the antecedent, which allows you to infer the consequent. In this messed up version, the invalid version, you have a conditional, and then you have the consequent, and from that, you try and infer the antecedent. That does not work. That is the fallacy of affirming the consequent. See, you're affirming the consequent. All right, so here's a counterexample to give you a visual of how this does not work out, right? So again, you could put this into a truth table. You would find that it's invalid, meaning there are instances in which the premises are true and the conclusion is false. Again, proof wouldn't help you much because you can't prove an invalid argument, so you would just keep going in circles. You'd hit a brick wall. All right, so let's use a counterexample to show an instance of this argument form where the premises are true and the conclusion could still be false. So first premise, if Ava has 1,000 followers on TikTok, then she is TikTok famous. Ava is TikTok famous, Therefore, Ava has 1,000 followers on TikTok. Certainly, we can imagine that both of these premises could be true while the conclusion is still false. It could be true. Like, let's just say it's true. Sure. If Ava has 1,000 followers on TikTok, then she's TikTok famous. That's a good amount, you know? Maybe we should increase that a little. I don't know what the bar is. And let's say that Ava is TikTok famous. Well, could it still be false that Ava has 1,000 followers on TikTok? Maybe she has 1 million followers. We'd still consider her TikTok famous, right? And maybe her first TikTok went viral, but not many people have followed her yet. So maybe she's like kind of famous, but she doesn't have that many follow requests yet. Okay. So the point is here that here's an example of how we could affirm the consequent, right? And that would allow the premises to still be true and the conclusion false. So there's a counterexample. This is a way that people mess up modus ponens or conditional elimination often. All right. So the next idea, and this is partially from the book, part of it is, but the next idea here is that some arguments, right, can both be valid and take the form of a fallacy. So I want to separate these two concepts of validity and fallacy or fallaciousness. I don't know what you would call it. Right. But I want to separate the idea of an argument being valid from the idea of it taking on the form of a fallacy. So first we're going to look at arguments that may take the form of a formal fallacy, but still be valid. And then second, we'll look at arguments that may take the form of an informal fallacy, but still be valid. Okay. So we'll go through two different examples here. The first is one that's in your textbook, the fallacy of composition. Your textbook acknowledges that oftentimes the fallacy of composition and the next one, the fallacy of division, are stated to be semantic fallacies. And I like them better in that category, but your book wants to put them here, so we'll talk about them. All right. The fallacy of composition happens when we invalidly impute characteristics of one or more parts of a thing to the whole of which they are parts. So it'll help to see an example from this. Okay, so if we have this list of things are parts of W and they all have this property F, therefore that thing W has property F. So the thing is, sometimes this works out and sometimes it doesn't. If we have, for example, tires are parts of cars. Tires are made of rubber, therefore cars are made of rubber. Doesn't seem to really work out that well, right? We wouldn't say that cars are made of rubber, but you can probably imagine why this oftentimes gets called a semantic fallacy, and that's because some of this seems to come down to what we really mean of, like, by the terms made of, right? It's made of rubber, like cars contain rubber. So maybe if we rephrased this, maybe it's a phrasing that causes us to commit a fallacy. And that is why oftentimes this is considered a semantic fallacy. But here, let's take a look at how this composition fallacy could happen in a valid argument. So here's an example where it does work out fine. My liver is a part of my body. My liver contains at least 1 million cells. Therefore, my body contains at least 1 million cells. And that one seems to work out just fine. So the point is that this top argument commits the fallacy and it's invalid, at least, if we're taking a surface level reading of it, right? It seems silly to say that cars are made of rubber. So it could be true that tires are part of cars, tires are made of rubber, and false that cars are made of rubber. On the bottom part, though, we have, look, this is following that same sort of argument form, but it happens to be valid in this point. In this argument, my liver is a part of my body. My liver contains at least 1 million cells. Therefore, my body contains at least 1 million cells. Okay. And again, I think it's better as a semantic fallacy because it's really about like what we mean by is a part of or contains at least. I think that matters here. All right. So the form of this fallacy has some valid instances is the point. So this fallacy, both of these arguments take the form of that fallacy, but this one comes out invalid on a superficial reading, and this one would come out valid on a superficial reading. Okay, kind of the inverse of this here is the fallacy of division. And this happens in the other direction when we invalidly impute the characteristics of the whole to the parts. So if we say W has property F, and all these things are parts of W, then does that mean that they all have property F, right? The fallacy would say that they do. So if we have, for example, cars can seat a driver. Tires are parts of cars, therefore tires can seat a driver. All right, so we wouldn't, this is a person trying to sit in a tire. Probably that wouldn't work out so well, right? So we'll say that the premises are true and the conclusion is false. All right, so that would be an invalid instance of this fallacy. But this division fallacy could happen in a valid argument. It might look something like this. California is in the US. Los Angeles and San Francisco are in California. Therefore, Los Angeles and San Francisco are in the US. So again, just like the composition fallacy, it seems that, semantics might be playing a role here. But I'll just leave it at that in terms of my disagreement with the textbook. I'm in favor of considering this a semantic fallacy. But, one lesson we can learn from this is that the fallacies and validity are two different things. All right, so the form of this fallacy has some valid instances. All right, so just a couple more notes. Hypothetical syllogism. We learned about this in chapter 4. HS looks like this. Here's another version of it. If P then Q, if Q then R, therefore if P then R. Right? So we know that that is a valid move to make. The thing is that we see this happen in the slippery slope fallacy, right? So the slippery slope has this form to it. It says if P happens, then Q will happen, and if Q happens, then R will happen, and if that means that if P happens, then R will happen, right? So you have this chain reaction that we saw, for example, in that DirecTV commercial, right? If you get cable, then you'll get frustrated. If you get frustrated, then you'll hit things. If you hit things, then your daughter will imitate, right? And you just keep going down this slippery slope. Well, the structure of it, the logic behind it is valid, but when you contain false premises here, right, making it sound like if you get cable, then you'll get frustrated, and if you get frustrated, then you'll hit things, right? Like each of these moves, at least some of them in that example would be false, right? Getting frustrated doesn't mean that you will necessarily hit things, right? So we would say that those are fallacies of false premises, and that's why they commit the fallacy. All right, so they can be valid and still commit a fallacy. So remember that validity is not soundness. So same thing happens with disjunctive syllogism. Here's that form, P or Q, not P, therefore Q. And we see this happen in the false dichotomy fallacy. If I tell my kids, I want you to wear the red shirt or the green shirt, right? And then they say they don't want to wear the red. Does that really mean they have to wear the green? Couldn't they just go to their closet and pull out a blue shirt, right? So the reason that false dichotomy is a fallacy is not because it's invalid reasoning. The reasoning is valid. It's because there's a false premise in that. And the false premise in that case would be to make you think that you only have two choices. You have to do one or the other, when really there's a third option or more options there for you. All right, so I hope that was helpful to see. Thanks for watching. This won't be on the exam. If you have questions, though, I'd be happy to chat about it. All right.